For this data, what we're going to do is we're going to organize qualitative data. We're going to do this through what's called the frequency distribution table, and we're going to do it for obviously for qualitative, which means like descriptive words that we're going to count. We're going to also make other charts later in these videos, so keep watching. We've got frequency distribution table. This is a method for making data in a chart form. We partition the data in a specific way to create this table, and a frequency distribution lists each category of data and the number of occurrences. So, an example of this, a physical therapist wants to determine the types of rehabilitation required by her patient. So she has a list of problems suffered by her patients, and we're going to actually go and do this in this video. So we're going to go ahead and I'm going to pull this up. We've got back. So each back, I'm going to put a tally. 1 back, 2 back, a hand. Okay, then we've got wrist, 1 back, groin, elbow, back, back, shoulder, shoulder, hip, hip, and knee. Neck, knee, and neck. Shoulder, back. Shoulder, back. Back. 1, 2, 3. Knee, back. And hand, back. And wrist. Okay, so let's make sure we got them all. We have 3 by 1, 2, 3, 4, 5, 6, 9, 10. 10 times 3, 30. So this is 12, 13, 14, 15, 16, 17, 21, 26, 27, 28, 29, 30. So we got them all. So the frequency. There are 11 instances of this. There are 2 instances of wrist. There is 1 elbow, 2 hips, shoulder, that's 4, knee is 5, hand is 2, 1 and 1. Relative frequency here is going to be 11 out of 30, 2 out of 30, 1 out of 30, and I'm just kind of doing this 2 out of 30, 4 out of 30, and I'm just kind of, sorry, I'm running out of space, 5 out of 30, 2 out of 30, 1 out of 30, and 1 out of 30. Okay, so we've got them all, and that would be our relative frequency table. Obviously, I'd need more space. I typically do this in class on a whiteboard, so I do have the more space, but you can see how it's done. So moving on. So we look and it says a relative frequency is the proportion or percent of observations within a category, and is found by using the formula relative frequency is equal to frequency divided by sum of all frequencies. A relative frequency distribution lists each category and data together with the relative frequency. And note, in a relative frequency distribution, we plot the percentage of data and is not the frequency like earlier. So that's, instead of it being, for the relative frequency, that's the bottom one, you're gonna plot the actual, these ones as decimals, whereas the frequency one, you'll do the actual frequencies themselves. And so, some things to note. We have bar graphs, and if you have a bar graph, it's constructed by labeling each category on either the horizontal or vertical axis, and the frequency or relative frequency on the other axes. Rectangles of equal length are drawn, and the height is represents the frequency or relative frequency. So you guys have probably seen bar graphs before. But we're going to actually do what's called a histogram. We can do the bar graph though. So let's do the bar graph real quick. So I'm going to use the plagiarism tool. We've got this. We're going to copy. Wait a second. Did I have 11 or 12? Oh, I had 12 here. I don't know why I wrote 11. Sorry. That should be 12. Anyways, apparently I can't count. So we have this, and they've done the calculations for us, but we'll do the bar graph. We have back. Actually, I need more space probably. So we've got, so it goes to 0.4, that's the highest, and it gets everything from 0.16, 0.04, so let's do 0, 0.05, 0.10, 15, 20, 25, 30, 35, 40, and 45. Notice I've spaced them basically evenly, but now we have back, wrist, elbow, hip, shoulder, knee, hand, groin, and neck. Okay. So let's do back. Back is 0.4, so we're going to just go ahead and draw all the way up to 0.4. Oops. Shade that in. And it's important that these are the same size and shape because we don't want it to be skewed. I'm going to do my best, but obviously it'd be easier if I had like the actual software. 0.06, that's going to only be right here. So we kind of estimate that at 0.06, a little bit higher than 0.5. 0.03, that's going to be half of this one. Okay, then 0.06. Okay, that one's good. And shoulder is 0.13, so that's somewhere like right here. I guess it should be more than double of this one, which isn't good because it means it's not to scale. But we'll live with it. 0.16, so that one's a little bit bigger. Okay. 0.06, that's right here again. We'll at least be consistent with the 0.6s being that high. Groin is 0.03, so that's right here. And neck is 0.03 as well. And there is our bar graph. Now this is a bar graph and not a histogram, because if it was a histogram, these would be actually touching, so you'd have something that looks like this instead. And so on and so forth. But we will do histograms, so make sure you're paying attention on that part. I'm not sure if we do it in this set or not, but if we look at the next one, it says the data represents educational attainment in the 1990 and 2013 of adults 25 and older who are residents of the United States. So 39,344 represents 39,344,000. Draw a side-by-side relative frequency bar graph of the data, make some general conclusions. So if we look, they've already done it. Obviously, this is not high school graduate on the left in blue. I'm sorry, the blue ones are the ones from 1990, and the other ones are from 2013. And so we can look at them, and let's make sure we know. So it looks like college degrees are on the rise since 1990 because the first one said not a high school graduate. There were a lot of those in 1990, but there were less in 2013. And then high school diplomas about even. And then some college, no degree is there. And then it starts to get slightly higher at associate's, bachelor, and graduate level. So we can probably say that there's a trend that more people are going and completing school in 2013 than 1990. And then the last type is to construct a pie chart. Simply take the relative frequency and multiply by 360. So for instance, this is 0.4. If you multiply that by 360, you get 40% of 360, which would be 144. So 144 degrees of this circle would be would represent back injuries if we were doing it in this case, but since we're not, just look at the relative frequency here. 0.1185 times that by 360, you get 43. And if you add up all of the degrees of measure, it will add up to 360 to fill up the entire chart. And it's sort of important to make sure that this chart kind of represents those angles. High school diploma, notice it's 107. Well, a 90-degree angle is a right angle, which is a left, it's basically like when the corner of a room, like the wall, touches the floor, that's a right angle, and that would be 90 degrees. Well, it's obviously bigger than that because it's 107 and not 90, and so on and so forth. So I hope this is helpful, guys. Make sure you practice these. There are homework assignments on this. I think you'll do fine. These are pretty straightforward, and we'll go from there. Thank you, guys.